Moshi moshi! Welcome back to another exciting video lesson on polynomial functions and end behavior. Now, why I'm doing this on the video lesson is because I feel like a lot of you guys are kind of familiar with this lesson and this idea. And honestly, we've been talking about this all throughout until this point. But we're going to formalize everything, okay? So leading coefficient, degree of polynomial, the behavior or the end behavior specifically, okay? And also the limit notation. And I think the limit notation is kind of new to some of you, right? Ooh, let's do that, okay? I think that limit notation is a little bit new, okay? What I'm going to do is I'm going to start with a table today, okay? Now, we already know that polynomials could go like this. Up, up, down, 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 up, down, okay? We already know that. We've talked about this a lot, right? But let's actually formalize it. I'm going to do that with the table. What's the table going to look like? It's going to look like this. Very fancy table. Whoa, super fancy. Whoa, and we're going to say this. Even degree, oddball degree. And I think we already know what this means, right? It's talking about the highest exponent in a polynomial, the degree of the function, the degree of the polynomial. And of course, we're going to divvy this guy up into positivo, negativo, okay? What do we mean by the positive and negative? Who's positive and who's negative? Miss Chang or you, right? Just kidding. We're talking about positiveness of the leader, the leading coefficient. The coefficient that's associated with the degree of the polynomial. That's what we're talking about, okay? Now, positive, let's actually just do this with the diagram. Positive and even, it's going to go up, 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 right? So it's going to go like this. Negative and even, it's going to go hella down. Both direction, baby. Okay? Odd and positive. It's going to go, wait, odd and positive? Is that a good thing or a bad thing? Let's think about this. It's odd, but it's positive. So it's going to go, oh, it starts off bad, but it ends up good, right? How about odd and negative? You're an oddball and you're negative. That means you all start good. So this is kind of dramatic, so I'll just make it less dramatic. It's like it's kind of ugly again. Sorry. I don't know why I can't. I'm a little nervous, I think, okay? You get the point, right? So it starts off positive, but it goes down. Like you go down, you start, it's kind of like your pre-cal grade, but maybe not really, okay? So chicos, it starts high up, and then it goes downhill from there, okay? Now, how do we express this end behavior? The end behaviors, like these end behaviors, using limit notations, which is very calculus concept, okay? So what are we going to do? We're going to go like this. The limit, I'm narrating as the limit. Ooh, notation, okay? The limit, I'm going to narrate this and then show you. The limit, L-I-M, as x approaches positive infinity. As x approaches positive infinity. Approaches is a key word there, okay? Of f of x is positive infinity. Okay? Wait. The limit as x approaches positive infinity. That means that x is getting really, really largey. Where is the end going? Is it going to go this way or this way? But in this case, it's positive. So which functions go this way as it's going to the right? So you can see that it's even positive. So I'll write that next to it, okay? So we're going to put even, positive. Who else? This way. It ends up this way. So it's going to go odd positive. Right? As it's going to the right, it's going to go up, 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 up. Does that make sense? Okay? If you don't, stop the video and ask me, okay? The limit as x approaches a positive infinity of f of x, sometimes the end behavior, it ends up negative. That means it's going to go to the right, but it ends up down. It ends up down. So think about the cases that makes this true. In the even case, it's when it's negative. Oh, sorry, not negative, negative. Okay. When it's an odd case, it's when it's what? Down, down, baby. Down, down. Okay, negative. Does that make sense? So practice reading that. The limit as x approaches positive infinity of f of x is positive infinity. That's how we say it, okay? Let's try the next case. Well, the limit could also go to the left, can't it? So let's do it on this side. The limit as x approaches negative infinity of this f of x is, we'll set it up twice. Limit as x approaches negative infinity of f of x. When is it going to end up at positive? Up, up. Or when is it going to end up negative? Down, down. So we're going to do the two cases, right? Okay, wait. Which of these, when you're going to the left? Earlier we were focusing on the right? Left. It's going to go to the left. When does it end up positive? So it looks like it's positive even, right? And also, odd negative. So let's write that. Okay. Positive, even, and odd negative. Now, if you don't understand what happened just there, think about it. It's going to the x is approaching negative infinity, getting really, really small. When is it going to keep going up higher and higher? Okay. Next one. It's limit as x approaches negative infinity, as f of x is going to negative. It's further going down, 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 down. So it's going to be this case and this case. So we're going to write those guys, formalize it. Odd, let's go off first, okay? Odd, pause, and even, neg. Okay? Now, does that make sense? The limit notation? Limit notation, of course, we're going to do a lot more with limits, but for now, the end behavior is all that you have to describe with the limit notation, okay? Okay. I feel like all this here is just talking about what's the end notation. Practice using your end behavior with limit notation, okay? Let's practice. Let's just practice one, okay? Okay, let's try a few. So let's go ahead and try this guy here. Number 1, use limit notation to describe the end behavior of the graph shown. Well, clearly this is I like to write things like this, even and positive. Don't look at the table here, okay? Just look at it and tell me the limit as x approaches positive infinity and the limit as x approaches negative infinity. Where is it going? Where is this function going is all you have to think. Oh, sorry, I forgot to write the f of x here, okay? Where is this guy going? Well, if it's going to here, it's going forever to up, up. So it's going to be positive infinity and negative infinity. Oh, just kidding, right? I was just kind of trying to not think, right? It's going to go up, 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 up. So it's going to be positive infinity here. Pretty simple, right? Pretty basic, okay? I'll let you guys think about the rest here. Limit notation to describe the end behavior. Well, when you're looking at a polynomial like this, you got to think if it's factored all the way out, right? If it's simplified all the way out. So we have a multiplicity of 2 here and a 1 here. What does that mean? Okay. I think you could try this on your own. This guy is optional for you, okay, if you want to do it, but it's not mandatory. And then the homework is attached, okay? All right. Ooh, I see a lot of corazón. Okay, make sure you try the corazones from the corazón, okay? All right, I'll see you later. Bye.